Kia ora Year 11 and 12. As promised, here is a wee video to go through the question that we did in class today. So this is question 6 off the Merit and Excellence questions sheet. So this question is a bit different from our usual trig ones because we're trying to show something. So it's a proof question. So let's read through it really slowly. We're given a drawing of a circle over here, and this is meant to say Q here. And the circle in the diagram's got a radius B, it's got a centre of O, and it's got a chord drawn from P to R. Right, so let's just draw that in again. So there's the chord. And we're told the length of the minor arc, PQR, is 20 centimetres. So that's the length of that arc there, right? Minor just means less than 180 degrees or less than pi in radians. And we're told that theta is the acute angle coming out from the centre. Then we're told that we have to show that if the shaded area, so that's the area of this segment, if the shaded area is equal to 1/5 the area of this triangle, show that the value of B can be expressed as this. So when we're trying to show something, we can't use that fact in our working on the way through. We have to start really basic and look at what we know. Well, the first thing that we're told is something about the length of the minor arc. So my arc length formula is S equals R theta. And here we know that the length S is 20 centimetres. And my radius in this question is B. So we can write that down. And we're just going to park that on one side for now, because it doesn't seem like it's going to be much help yet. Then we're told that the shaded area, so the segment, is equal to 1/5 the area of the triangle. So we're going to start by writing down what can we say about the area of each of those things. So the formula for a segment is the best place to start, and that is A is equal to 1/2 R squared theta minus sine theta. So in this example, we're going to now substitute in the values from our segment. We've got 1/2 B squared theta minus sine theta. Alright, I'm going to call that area 1. Okay, that's this thing here. Now, what about the triangle? Well, the formula for area of a triangle, which unfortunately I've also called A, just out of habit. Let's call it X instead, okay? So area X is equal to 1/2 BC sine A. So that's the included angle and these two sides. Right, so ordinary old area of a triangle, year 11, year 12. In our example, that's going to be 1/2 B times B, so B squared sine theta. So that's area 2. And we're told that the shaded area, so the segment area, is equal to 1/5 the area of triangle POR. So what I need to do now is to take this and relate it to this in an equation. And we know that the segment is 1/5 the area of the triangle. So I'm going to do that on a new slide. Alright, so what can I say? Well, I've got 1/2 B squared times theta minus sine theta is equal to 1/5 of the area of the triangle. So I can look at that, and I've got to now look at where I'm trying to get to, because this is starting to get a little bit messy. Well, remember my goal here is to show that B is equal to 50 over 3 sine theta. So I can see some stuff coming through in here. What I'm going to do is do the obvious things with this equation and then see what else I can pop in here. So I need to clean this up a bit. I've got a common factor of 1/2 on both sides, and I've got another common factor of B squared. So I'm going to divide both sides by 1/2 b squared. And that's going to leave me with theta minus sine theta is equal to 1/5 sine theta. Right, now we'll keep on cleaning up. We've got some like terms here. We've got a sine theta here, and we've got a 1/5 sine theta here. So theta is equal to sine theta plus 1/5 sine theta. And that gives me, this is 1 sine theta, so this is 6/5 sine theta. Right, so we get down to here, and we sit, and we look and go, well, I've got no b in there at all. I've got a sine theta, so how on earth am I going to show that? Then think back to the one fact that I haven't used yet, and that was, let's just draw it quickly here, that the arc length of that minor arc was 20 centimetres. So we wrote really early on that 20 equals b theta. What I want to do now to get b back in is I'm going to rearrange this as b equals, well, first we'll go b equals 20 over theta. Now, is that really going to help me? No, it's not, because what I want is an expression for theta in terms of b. So we don't want that, but we do want this. Theta is equal to 20 over b. Now, substituting that in here, I get 20 over b equals 6/5 sine theta. This is the point where you should start feeling a little bit excited, because you can start to see it looking like where we want to end up. Now I'm going to do some slow cross multiplying here. First I'm going to multiply both sides through by 5. We'll get 100 over b equals 6 sine theta. I'm going to go to a new slide because this is far too messy. Okay, so we've got to here 100 over b equals 6 sine theta. I'm going to multiply through by b. 100 equals 6b sine theta. And now I'm going to divide through by 6 sine theta. And we get 100 over 6 sine theta equals b. So b equals 50 over 3 sine theta. So what I've done there is I've divided numerator and denominator by 2. Okay, and that's what we need to show. So when we've done that, we typically write as required at the end. Okay, I hope that helped. Try it for yourself and make sure that you can go through all of the steps with the algebra at the end.